All right. Hi, everyone. My name is Aditya, as Nicola just mentioned, and I've worked for Salesforce. I've been there for 4+ years. All right. So today we are going to talk about the NLP text recommender system we built, one of the many machine learning systems we have worked on. And we'll go through the journey from right from the beginning till where it is right now. And that will hopefully bring in useful lessons for folks listening in. All right, so the agenda. So we'll talk about the problem space to begin with, give a bit of a background on the enterprise problem we are solving. Then we'll talk about the approach we took and the metrics we care about for the approach. Then we'll dive into the various evolution phases. So we'll talk about how we started small and moved on to something which we have right now. Then we'll jump into the architecture, talking about the various phases, serving, feature engineering, and training. Finally, we'll talk about the deployment rollbacks for our model. And then finally wrap it up with challenges and takeaways, hopefully summing it up and something useful, actionable for the audience. All right, so the goal. So the goal we have is to assist the customer service agents with useful answers, which they can use to help the consumers who have the problems. So that's the maybe the high level goal we are trying to achieve in a simple way, right? And the scenario we started in was that the agents who are trying to assess the customers, they have access to for example, search, the traditional text search, which is heavily relying on the actual text, not really a lot of semantics behind it, but it's purely relying on the text of the question to find the answers for the agents. The problem is that these questions are normally very long because they are explaining a problem which the customer has about a product, and they are generally not easily searchable as it is. So that is the problem we started with. So we obviously needed to fill this gap, and we came with a solution. So first of all, what's the business metrics we are trying to improve, right? First, that should be talked about before we start talking about the approach. So the business metric is that we want to, the first one is we want to reduce the time to resolution, right, for the agent. So the earlier, the faster they're able to resolve a case, they can go on to solve the next one. At the same time, the customer satisfaction, everything goes up. So that's the key business metric. Then we also have a soft objective function, which is transferable into our system, which is the case to article attach rate. So article is a representation of an answer, and the attach rate is a good representation of how close the article is representing the problem, or solving or helping solve the problem which the customer has. Then we also want to track the time spent per case. Even though there might not be a resolution, we want to improve on the time spent. So we want to ensure that the agent is able to move on to a next one if they are not able to completely resolve the case, but they are able to increase the throughput. So that's another key metric, right? Then there's secondary metrics as well. So some of the secondary metrics are number of recommendations served, which is a measure of scale. Then the monthly active organizations, because being an enterprise company, Salesforce has companies running on us. And so the platform we support has like thousands of organizations, right? And we want to keep a track on how many of these organizations are onboarding with us. And every organization has a lot of users, and users are agents and administrators and other profile users. So we want to also track how many of those are actually using the system. So typically for us, it's we care about the agents, like that's like those are the central users. And then the serving latency, we want to keep that low because that's very key to user satisfaction and helping the time to resolution as well, actually. All right, so yeah, guess what? We built a recommender system. No surprises. We had that in the title as well. So what's the architecture like, right? I mean, what is the high level flow? So you can see that we have a corpus, which is in our use case right now, this specific product we are tackling, we are caring about the knowledge articles specifically. So we consume the knowledge articles into our pipeline. We go through the first phase, which is targeting recall. And the goal of this first phase candidate generation is to get enough candidates for the ranking layer to rank on. So So from hundred thousands of articles, we come down to a smaller set, which is of the order of thousands and manageable by the ranking layer. And finally, the ranking layer, which is a precision layer, scores the candidates, and we get the scored results to be rendered. All right. So yeah, as I was mentioning in the agenda, right, we'll go through the evolution quickly just to give you a sense of how it came to where it is. So the version 0 was obviously without a model. We wanted to build a proof of concept and kind of really show that this is something which will add value. So luckily, like the use case was, as I mentioned, like was very clear that we are trying to reduce the time to resolution, and the customer base was already there. So we wanted to first showcase that, okay, if you build something like this recommendation system, what will be the experience like? So that was the first cut. We definitely pushed on getting our pilots onboarded, because they were more like the pilots as in the beta customers, and they were like more like partners, right? The first few are always your partners, and that's what we also focused on, to learn from their experience and have very continuous feedback coming in. The first cut was built for communities use case, where it's like a social network. So questions are coming in. There are posts which have, some of them are questions, some of them are plain statements. But there's a lot of repetition there. So there was a scope for using a system which could reply back automatically and reduce the customer, or rather improve the customer experience by giving back a known answer instead of someone, a human, trying to respond back every time, right? So yeah, so that was the first cut. We definitely started thinking about the modeling as well, and we relied on the Stanford Score data set, which is a very popular question answering data set. Then coming to version 1, we started focusing more on the ranking model itself. The second part of the flow, where we wanted to see that, okay, how can we improve on the precision? That is where the value addition was on top of getting results back from our candidate generator. So we focused on getting a ranking model, which did pairwise probability scores on the question and the answer, which was like the case and the article pair. We did the model training in notebook based on-demand training was done, which was like specifically for the initial pilots I was talking about. And then we had static configuration, right? The data set for one thing to highlight is Salesforce has very complex data schema, and the customers, that's why Salesforce is so popular as well, because it lets the customer really kind of adapt to the data model to their business use case. But then that also has complexities for us to know where their data lies, right? Really, what projection and selection they really have for where they're going to store the data. So initially we didn't kind of tackle that. We had a static configuration for like the default fields we used to get the data in. And then we started thinking about the observability as well. So the logging and metrics, we wanted to get that in early. So yeah, in version 1 there were hints of these things coming in. So in version 2, this is like more, maybe like we can go version 2 3, but I've just summed it up in version 2, where some of the key pieces were, which we were working on earlier, they were built. And we started supporting dynamic configuration for the customer to specify the selection and projection through a set of flow. We also invested heavily in the model retraining aspect and the model management. As we will see in the coming diagrams, we will see that model management and retraining is very key to our success, because it's not that we are training just one model, we're training multiple models, and it's being a multi-tenant platform, right? And then we also like went on to support different languages to support our European customers beyond English. And yeah, that also was a major milestone, I would say. Then yeah, model deployment and with rollback. So we also invested heavily in the DevOps cycle, so that it's not that we are, every time we want to make a training code change, we have to invest a lot of time. So we kept that in mind, and we have now come to a point where our rollbacks and deployments are pretty stable. All right, so let's talk about the architecture now, a bit overview of the two parts, like the serving side and the training side, right? So let's start with the serving. So for us at Salesforce, right, the first let's see who the users are really, right? At the bottom right, you can see we have the customer, which is the end user, like us, who will go to the support system and they will create a case directly, or they will probably be chatting with an agent. So that is where this channels comes in. There are multiple channels. It could be chat, voice, it could be email, or it could be directly creating a case. So once a case ultimately is created coming in through either of the channels, that comes into our backend, it is fanned out, and we have our message queue system to scale things up. And then on the other side, the handler starts triggering the answer engine or the recommendation system, which we talked about earlier, right? So the two stages were the candidate generation and then the ranking, right? So the case handler will be doing it for thousands of cases parallelly. The answer engine is the candidate generation is kicked in. It will talk to the search index, which is one of the key sources for us to get back the candidates. So in candidate generation, what we do is we extract the key terms from the incoming question. So the question is like a huge blob of text, right? It could be a very long paragraph for all you know, and we want to formulate a query which can be understood by the candidate generator. So one of the candidate generators is search, and we have our own custom rule-based technique to uh, formulate multiple queries, which will ensure we get our target number of candidates. So we do that here in step number 4. And then finally, 5 is like the generation part, which is consumed by the ranking and the cutoff tier. And there, the ranking or the ranking model kicks in. It basically will do pairwise scoring of the incoming question and the articles which are given by the candidate generator, right? So it will do pairwise scoring, and then the pairwise score is finally available to the agent. So we pick up the top K recommendations back to the agent, and this is happening in real time in a way, right? The customers have creating, talking here, asking questions, and we are recommending the results or the answers, the assistance is coming to the agent in real time. So yeah, so this is the main flow, but let's not forget other personas. So we have the knowledge base admin here, and then the org admin here. So these two are important personas as well. So they are also users of Salesforce platform, right? And their role is to manage the knowledge base, for example. So they are the administrators of the Salesforce org they are using. So they will create the initial corpus. They will also maybe like do the language translation in kick off that process. Those kind of things are done by the admin. And then the org admin is the persona where who is responsible for managing the product we are building, right? The recommendation system. So they have access to the setup flow, and that is where they specify what data set, what view of the data is important for training. So that's the job of the org admin. And only the org admin would really know about the org, because every org has their own requirements. All right. So, and then last but not the least, we have some more tools out here. Like the metrics UI is very key to give feedback to the user, in our case, the org admin, to know about how well the whole system is doing for them, whether it's adding value or not. So that's where we showcase the data metrics, the model metrics in a format which is consumable by them. And then last but not the least, the Salesforce internal user is also having access to certain tools for troubleshooting our own system, right? So any distributed system, especially a machine learning system, is bound to have need for troubleshooting at points, and we have internal tools which lets us in a very safe way help resolve the problems. All right, so we talked briefly about these two layers, right? So just to highlight and summarize it. So the first layer is doing the key extraction based on NLP techniques. So we use libraries, open source libraries. At the same time, we have custom trained models to do the NLP key term extraction for part of speech extraction, named entities, noun adjectives. Those are some of the aspects we care about from the question. Finally, the query formulation kicks in, and we generate the query, which will be understandable by the candidate generator. In the ranking layer, as we talked about, we do the pairwise feature generation, And that is where we ultimately get the scores, right? And we rank the probability scores in order, and whichever is above the threshold, that is what gets recommended. Talking about the other side, right? We talked about the serving now, and let's quickly look at the training pipeline. In the training pipeline, the first part is the feature engineering, right? So feature engineering, data preparation comes under the same umbrella. And the first part of that also is the ingestion part. So we have to ingest the data into a place where the training and the feature engineering can happen. So typically, in a consumer world, the same system could act like like the same database could be suitable for doing feature engineering, but in a enterprise setup, we cannot really have the same runtime system also be used for feature engineering. We have to move it to a place where it can be, we can do further analysis and kind of run a pipeline on it. So we do that first step as an automated step, and that's moving the data from our system of record into a data lake. And then we have quality checks after that, once the data is moved over. And then we do the feature engineering. We'll talk about this briefly again when we look at the diagram. All right, and then like after the feature engineering is done, then the model training kicks in. The ranking model will be basically trained, and we use auto-tuned hyperparameters. That is basically with grid search on, we can auto-tune the hyperparameters. If that is not on, then we rely on the default hyperparameters which we have configured at from the runtime. And then we also do model comparison, because since we have automated pipeline now, we want to have a system where the models are not just the latest model is not always the one which is sent back to the serving stack. We want to compare and find the best version. There's always a chance that there's some regression and the latest trained model might not be the best performing one. So we do rely on evaluation metrics like the ROC, AUC, PR, AUC, and then the other metrics like F-score, precision recall. Hit rate is at K is also used for accuracy measure, and we compute this across all the cases. Cool. So the hyperparameter tuning, as I was saying, so this is just an example of some of the parameters we use for which are consumed at the time of training, and that kind of controls how the model will be trained. For example, the grid search on, if it is true, then we kind of have auto-tuned system. Then these parameters are not used. Then we have the sample size. Yes, the sample size, random sample size is another parameter we use to define how many random samples we are going to generate for the negative labels. So as we were looking earlier, right, we ingest the data, but the data we are ingesting is more positive samples. Like we are the data we consume in is more representing the data which the customer has given a thumbs up on. So some of the articles which they have attached to a case are positive labels. We also want negative labels, and for that we do some techniques on our pipeline where we randomly generate some of the negative samples. And this is one of the parameters which control that. Then we have the maximum number of iterations we want at the training time, and some other metrics are there as well. Okay, so this diagram is giving you an overview of the whole flow and some of the things I just talked about. So you can see, like on the extreme left swim lane, we have the multi-tenant platform aspect, where the orgs, the customer orgs, they're of all size and shapes, right? And we want to support all of them, cover all the corner cases as we start the training pipeline. Once the auto ingestion happens, we focus on the data entities we are going to use for the training flow. Some of them are the case themselves, the articles, the attaches, which is representing the positive labels. Then we have the corpus stats, which is representing the some of the statistics about the article corpus itself. We do some pre-computation for it. And then the n-gram stats as well, which is pre-computed, which represents the unigram, bigram overlaps from between the cases and the articles. So some of the stats are computed here, and some of the frequencies are pre-computed, which is going to be used in the next phase, basically in the feature engineering, and then eventually training as well. In the data prep and feature engineering, we go through some of the well-known steps. We do the initial for missing data, some of the missing values, we do data imputation here, filtering is done. Then eventually we have to do the quality checks as well to make sure that after all the missing values are filled up, null values are dropped, we still are reaching a minimum bar for the training to happen. It's very much possible that after when the organization data is ingested, we reach a point where we can no longer train the model because either they don't meet the quality bar, or they just don't have enough data. So that's like a cold start problem we have to talk about as well. Then we then we do the NLP feature generation. So this is where we use the pre-computed data, the n-gram stats, the corpus stats, and we do an overlap between the case and the article sections, like the description, title, the body of the article, things like that. So those are the key aspects which are used to compute the overlap. Once we have the basic set of features, then we do feature crossing to expand on the feature set. Then finally, we do the feature selection to make sure we don't have features in the system which are not adding value. All right, and then on the learning side, on the model training side, the feature weights are learned. Once the feature engineering stage is done, then we get on to learning the feature weights. The model is validated using the validation set. And then finally, we do the model comparison, which is then eventually sent over to the serving stack. So on the bottom you can of the diagram, you can see there is a training loop flow, which is representing that we actually have a system which is running automatically. We don't have any manual intervention in a normal scenario, and the data is ingested once the model is trained, and it is serving recommendations. There is a state-driven training orchestration, which basically will basically invoke back the training loop, and the same process happens again for each org. And this also happens for new orgs which is coming in. So the same orchestration flow is also used for kicking off the training pipeline. Cool. So, and then finally, the service agents are able to get the recommendations from the app. How much time we have? Okay, I think we are good on time. Then let's talk about the model deployment part, right? So there are no surprises here on the first part of the flow. This is a typical CI pipeline where which we actually we didn't have in the beginning. We didn't have this. We invested specifically to improve our developer throughput, and also ensure that the deployments are stable. So as you can see, once the training code is updated by the developer or the scientist, then that gets, we do a git commit push, and that gets bundled in, the training code gets bundled as a binary, that gets bundled as an image, and that gets pushed to the container registry. So that happens, this is the automatic flow we have here. And then on the bottom row, you can see the DevOps. We still have a pseudo automated flow for the DevOps to ensure there are whatever approvals we need to ensure the quality of the deployment that is supported. And the DevOps kicks off the deployment process, and we have a rollback mechanism where if in the test environment we find any issues once the sanity tests are run, we are able to very easily do a rollback and deploy the previous image. And if there are no issues, then obviously our deployment cycle moves on to deploy the in the production environment. Cool. Zooming in a bit into the deployment itself. So we have a cloud native approach where we ensure our container, the container which is used for the deployments, that is that we can very easily move to a different cloud for all you know. And this is also very easily tested on a developer box, right? So it makes it very simple for us to test things locally, deploy it, and do it multiple times a day. Some of the parameters we consume here are the hyperparams for controlling the training itself, the data sets which are used for training on, and then some of the configs which are used for housekeeping in the container. Once this training is done, the model is generated. It is pushed onto a storage bucket, which is a well-known bucket for the system, and it is hosted behind the model API for the serving system to pick up from. Cool. And then let's talk about the challenges and the takeaways. That is where it's a summary of maybe not everything is captured here, but it's still a decent list of things we have to take care in our while we build this system, and also we'll talk about the takeaways next. So for us, we had to deal with non-standard data shapes, right? Like it's not that the incoming data is different for every customer, as I was hinting earlier, and we have to keep the system flexible enough to take care of all corner scenarios. And when I say custom data fields, so Salesforce lets the customer define their own fields and the data types as well. So that makes it a bit tricky for us to handle that in a training pipeline. But obviously, like the corpus is limited, and we have our checks and balances in the training pipeline to take care of this. Then the model management. This is also very specific to, I think, our enterprise setup and for us, because we are not just training one model or a couple of models. We are training hundreds of models, and that is happening in an automated fashion. And we also take care of retraining them as data drifts. So that's another key challenge, and I think this might be common to many enterprise setup companies. Then siloed data sets. We also have the data sets. We don't cross boundaries, so that's something which has its own downsides. At the same time, the security aspect is also another thing tied to the siloed data sets. So which I have covered here under data. So we have to keep an eye on the compliances, encrypted data sets, and then the quality of the data itself. If it is too sparse, as I was mentioning in the diagram earlier, if it is too sparse, then it might not even be ready for training. So that's another problem. Freshness is something we have to ensure that the data is hydrated continuously and not let training serving skew happen as a result of that, because the serving side can very easily be having a very different data shape compared to what the model was trained on. So that can very easily be a problem which can occur if one is not careful on retraining the models with the latest. Yeah, and also, like, if the data is too dense, right, like it for us, we have to make sure that we are sitting within the SLA bounds and also the cost bounds. So that's another key thing we have to take care of. And then finally, the cold start problem. We talked about the training serving skew. That can happen because of like if the libraries are not shared across the serving and the training side, if there is a feedback loop, for example, from the model back to the algorithm, or like the data shape is drifting. So these are some of the reasons why this skew can happen. And then the cold start problem, where the company doesn't have the data, so we still have to have a way for them to get started. And we solve that by providing a default model, which is not the best performing model for them, but it will be something which they can bootstrap on. So yeah, finally, to sum it up, some of the takeaways we learned and I'm sharing here is that, yeah, iterate, no surprises there. Build small, like we started with a POC. So that's an example of how one can iterate, start with something which works and then keep adding complexity. Also, like the model interpretability is super important, especially in the beginning when you are also trying to understand whether understand the data and understand the use case in depth. So starting simple interpretable models like logical regression, for example, random forest, those are great starters for some of the problems like recommendation system as well. And then, yeah, prioritize the infrastructure, because that the ML tech debt paper kind of talks a lot about it. And yeah, if it can easily build up and bite you if it's not taken care from the day one. And first, a few beta customers, very important, because they are like your partners and they are helping you improve the system. So that's very important. We want to make sure that they are super successful, and the use cases they have are taken care of, because majority of the use cases will be similar, if not exactly the same. So yeah, this is super important as well. And then scale the model to the size of the data. Like if your data set is small, then maybe deep learning is not the best solution to begin with. So yeah, something to highlight there. And finally, data privacy is super important. Like even if you are getting a minor improvement on quality, I think there is no reason to sacrifice the privacy of the data. Cool. Yeah, I hope I didn't overshoot. Any questions?